Okay. So, hello everyone, and welcome to this session, and thank you for being here and for taking some part of your time to listen to this talk. I'm Pietro, and I will be talking about a topic that I'm passionate about, which is domain expertise in data science. And the idea of this talk is really to try to address how domain expertise impacts the project. I will draw stories and ideas from my experience, and I will explain you one domain, because really one of the things that I like is learning about different domains. And so one of the goals of this talk is to encourage more people to share about their domains and motivate them to do this kind of stuff. The slides, you find them on GitHub. And I have written that also on the whiteboard for them. So, the talk will be in three parts. First, we will try to convince you that domain expertise is important, although I guess since you are here, you probably are already sold. The people will have to send the video to the people that are not convinced about that. And then I will talk about the domain I've worked in the past 10 years, which is logistics and supply chain. And I try to make a condense of the parts that I know and I can explain. And then starting from some stories from experience, I will give some ideas of why this is important in general, giving specific examples. And I will be touching also some technical part, which is the part that I mostly worked on in this specific domain, which is the part of forecasting. But there are other parts, for example, in this domain it's very important also the optimization parts, so the part where you use operational research technique, which is not something that I will touch a lot about. So, to put it a little bit in context, I am Pietro, these are my emojis. And the reason why I want to put this in context, this I took it from a wonderful keynote of Python International company. These are my emojis. And the reason why I want to put this in context is also because you will have a way to understand where I'm coming from and so adjust if I say incorrect things or something like that. I think this kind of talk for me is new, this idea of talking about the domain. So, a little bit of background. I have a background in math, and I went in applied math and I started learning about different domains. So first I did not finish a PhD on climate dynamics, so math applied to climate. But I ended up anyway getting a postdoc in cryptography, changing complete domain. And then I spent almost 9 years as a data scientist at this company, Tools Group, where we were doing the software for supply chain planning and optimization. So a lot of the material that I was talking about is about this company. Not all of it, and then I decided it's time to move on after 9 years, and I went to PyData Amsterdam. I loved it so much that I decided to start a PyData Milan chapter with the people that were already organizing the Python Milan chapter, and so it's really special for me to be here. It's my second PyData, already here in New York, across the ocean. Another reason why it's particularly special that I'm here is because last year, during this professional break, I did something which is called the Batch at the Recurse Center, that if people are around from here, they may go or not. It's a place for improving your programming skills. I'm a data scientist who like programming skills, and do also non-data science stuff. Sometimes on the side of programming. And it's a really, really nice place. So I had the chance to come here for a week and spend 2 days there, because when you're around. And I invite you to check it out. It's a very special place. But since the last 6 months, I've been working at Agile Lab, which is a very interesting company. I mean, I can say because just 6 months ago I was just looking at this from outside, now I'm inside. It's an Italian company consulting in software engineering, specializing instead on the data engineering and big data. It started as two guys who said, okay, we want to do a company different like the ones that we do in Italy, innovative. So it took up many innovative practices. One of these is the fact that we have a public handbook. So everything that we do is the policy, most of the policy that we have internally are there, and there are a number of other things. And we are now on around 200. And actually 2 years ago we started, 3 years ago we started investing in a product, and to do that we're looking for investors, and we ended up getting acquired by Poste Italiana, so the Italian postal service, which is the biggest employer in Italy, 120,000 people. So we are part now of this group, which gives us some opportunities of doing interesting stuff. So, domain. Let's talk about why domain is important. So when I started my journey in data science, I was working from Italy, which from here I think it's like a feeling that you are on Tatooine, a province far away on the empire. So you start reading a lot about, what's the data science supposed to do? And I found out about this, the data science Venn diagram, which tells you, okay, the data scientist should be one that knows about math, statistics, let's say algorithm part, the models, but you should also know how to code because you have to put that in production. And there was this third thing about the fact that you should also acquire domain expertise. And data science is really at the intersection of these three things. And so yeah, this is good because I like learning domains and those things I can do. And then looking back now, after 10 years, when I started reading, at some point I realized, okay, in terms of these three things, I can find a lot of content about math. I mean, I can go and sit around sipping some whiskey and, and reading about how transformers are from scratch. Or you have every moment a new article about something else, now that you can access Google Sheets, but domain expertise not so much. So that's one of the reasons. So to inspire this talk, to try to motivate more people to produce material on that, and doing my part, then if you like it, then it's up to you. And I think also this part is important because it's a critical ingredient of the success of a data science project. We are often, myself included, trying to focus on the technology part, on the fact that well, you need to have data quality, you need to have a model that has a good accuracy or whatever, and the implementation needs to be good as elements for the success of the project, which are for sure required. But more often than not, I feel that the business side is very important. So the thing that you build, the tool that you build, you want it to be used. In order to be used, it needs to be valuable for the business, and you have to convince stakeholders, and that's the part where sometimes there are politics involved or whatever, and that's the part you can do only so much about it. And there is also another part of inspiration for this talk about domain-driven data science. And here, just as a disclaimer, I will talk about two topics on which I know very little about. So if you know something about it, be kind and tell me about it later. But it was part of the inspiration, and it has something to do with the company I'm working on. So, and the fact that I try to follow up with software engineering practices. So the company we work with in Agile Lab, one of the ideas that we have is that, in a sense, the data world is new. Software engineering is also kind of new, but kind of older. So some of the practices that you see in software engineering will get somehow translated in the data world. And one such practice is that a number of software engineer friends from Milan told me a lot about it, and it's something that we study inside the lab, is domain-driven design. Which is something which there are conferences about this. Butchering this concept is the fact that developers should know about the domain they're implementing application in order to build better application. One idea I particularly like, which is central about domain-driven design, is the fact that there is this thing called ubiquitous language, and developers and business domain experts should talk, and you should use in your application the language of the experts, because in some way that helps you also to model. This is particularly important in the OOP world. So how do you structure your object hierarchy, and so on and so forth. And this domain-driven design actually is something that got ported instead to the big data world. I am a data scientist, so until I applied for a job at Agile Lab, I didn't know anything about data mesh. Who knows what data mesh is here? Okay, so the same as my experience, okay? And you cannot tell me. Plus, I discovered that the videos of these talks come out in January, and that's good, because I have a probation period, so I will butcher this topic in which we are experts. This is great. So, data mesh is domain-driven design for big data, but the way I understood it and the way I perceived it also as a data scientist is, okay, in the old big data world you have business experts on one side, the data analyst and data science on the other side, and you have the data engineer that build the big data lake in which all data goes in, and the domain experts and the data analyst and the data scientists do not talk each other. Okay, so the idea is to, in data mesh, as far as I understood it, is sorry Paolo, is to build vertical teams. That they are responsible of a data product, which is of a particular domain, which is not only a table or something, but it's something that has processes, has policies implemented, and you can read more about on our blog. And part of the knowledge, and data mesh is something that was started at ThoughtWorks, which is a thought leadership company in software engineering. And we now have built a product that integrates some of this thing, and our CTO became a thought leader in this area, basically, as far as, so it started in the US with Jean, the guy who went on to create a company for that, but Paolo is now a recognizable person in Europe for this concept. I was very impressed when I learned about this. And we also have a podcast on data architecture in general. Okay, so let's get down to business. Check my phone from time to time in order to not overextend my stay. So the domain I worked on the last 10 years is logistics and supply chain. So it's the old part of this domain is logistics. Okay. Which is something that has been going on for forever. And every logistics book I consulted, they always started with some quotes about some general or here from the art of war, of the fact that logistics wars are won on logistics. If you don't have the supplies, you don't have the food to nourish the military, you don't win wars. But it is also something that is now central for the global trade, how we are now exchanging and producing goods and moving goods. So the thing is that you have, you are either producing, manufacturing, or distributing something, or buying and moving it and selling it to customers. So you have supplies from which you buy either the stuff that you're going to sell or the ingredients, the raw materials to manufacture something, and the customer on the other side. And there is the materials, so the goods, the physical things flows from the suppliers to the customers, while the information flows from the customers to suppliers, because the customer are interested into stuff, into this product or to this other product, depending. And so there are these two flows. And inside the organization, let's say the three main functions are the fact that you have to acquire what you will end up selling. You have to usually do something about it. Either you manufacture it, or you package it, or you move it around. And then you distribute it through a network, through warehouses, through shops, through all these kind of things. And logistics, at the beginning, it was something that it was more silos. Every one of these functions were working on their own. And then it started to become more integrated in the organization, so to optimize the whole end-to-end operation over there. So two classic parts of which are responsible logistics are the storage part. So you move these goods around, you have to put them. And we also see why you have to put them somewhere. You cannot just move them. And you move them around with ships, with trucks, with people bringing letters to your door. Since we are talking about data science, AI, and everything, I want to touch a little bit about the topic of automation in this area logistics, because it's also part of the story of my previous company, Tools Group. Because in the 90s, the idea, and it's still something that is important, I think, to the industry, but it's not the part I will be talking about, so it's a sort of a disclaimer. I'll give you the reason why. The idea, sometimes people associate, is the fact that the intelligence, the data science part of logistics might be automating the warehouse, so things that are very smart and do all sorts of things. And the people who started the Tools Group company were starting an automation project in the spare parts of Fiat FCA at the time. And they actually discovered that instead of having this, automation requires a big investment and you have to maintain it, you're not sure. And instead of working on the automation part, they could work on the process of how much stuff do you order, because these warehouses were full of stuff you were not using and selling. And just by focusing on being smart about how you do things, you can actually, with a very small investments, gain a lot of cash and financial gain, and also agility in your supply chain. So this is how logistics evolved into a concept which is called supply chain management, which was actually invented by Booz Allen Hamilton, or something like that, the consulting company in the 80s, with this idea that the companies are now in a network of suppliers and customers, and they don't have to compete with the rest of the network, but they want to cooperate, because if they make their life easier also to their suppliers or to the retailer to which they sell, if they're a manufacturer, this actually helps them, helps the whole value creation chain. So what happened in the modern world is that in general, in the last 50 years, 40, 50 years, the network of suppliers gets extended, you have things abroad, the market becomes much more demand-driven, so instead of manufacturers who say, okay, we make this product, we ship it, and you buy it, okay, I buy it, and now the customers are more, the consumers are more, okay, no, I like this one, I like this one, I only buy it in promotion, and the organization compete on two things, not only cost, which I would say is the most intuitive thing that you want to do a lean operation, but also service. And service means the fact that when somebody wants to buy something, you have it on hand and you can ship it. That you can ship it very easy. That you are reliable when you ship stuff and you always find it. So it's it's really, you can think it a bit about service at a restaurant. It's not just about how good the food, but how the experience of going there, and the people come and take your orders right away, and they are quick in preparing your food. That's part of the experience of a restaurant. And increasingly, the demand part and also the supply part, there is more turbulence and volatility because of pandemics, because of container ships that get stuck. So you need to build supply chains which are robust, reliable. And that's as far as the general description of supply chain. I'll try probably to move a little bit faster. So one of the things that I worked about was on the planning part. So planning is about having a plan for the future and executing. There are three things which are important. In building, for example, a tool that provides planning capabilities in this area. So first, there is the first thing that you can build as a data scientist, let's say, is a demand forecasting system. Okay, so it's something in which you have past demand, which is 10 boxes of this, 12 boxes of this, and you produce a forecast. That for supply chain is very important. That it is a probability forecast. That's why I added some error bars there to indicate the fact that it's important that it's probability. You will have stock in warehouses, and how do you manage that? The classic example, let's say the minimal example, is the fact that for every product and every location, you have a min and a max level, and when your stock goes down on the min level, you order. And then your demand makes it going down, and you order again. And you have to decide what are those min and max levels, and that depends on service. And now I'm taking a more narrow definition of service, the fact that you want to be able to satisfy, 90% of the order that come in, okay? Or 90% of the quantity of the orders that come in. There's always also a distinction between order lines and total quantity. And the relationship between stock and service, since the demand has to be considered always stochastic, is the fact that you cannot aim for 100% service, you cannot aim to always be able to satisfy the order that come in, but the more you increase the service, the more the stock goes up, okay? And you use this kind of stock to service curves to decide that tell you what are the levels. And from a system like that, which is an end-to-end system for doing planning in the supply chain, you can then try to optimize it for various objective functions that you can have, cost, volume, stuff that is food that goes rotten, and so you want to sell it before and stuff. So there are, in terms of the element that we have to take care of, one big element is uncertainty, because the demand is uncertain, but also the supply is uncertain. You're not really sure if your supplier will have the stuff that you want to buy, and if it arrives in time, in the correct quantity. So one important concept in this domain is the concept of lead time, which is a generic concept, but in the context of supply chain, there are dozens of definitions of lead times, but in general, the most simple one is the fact that when you have the stock diagram and the stock is decreasing because people are buying your stuff, at some point you place an order, okay? You place an order and the order does not arrive right away because it's not software that you buy and you click and it arrives. Are physical goods that needs to be moved, and so they need to be sent in truck. And so the order can arrive at this moment or at this other moment. Okay, so there is an uncertainty in the supply. Okay, can even not arrive the order. And what happens is that also the demand, maybe you thought it was going this way or going this way, okay? And so the delta between the moment you place an order and the moment the order arrives, which is stochastic, is lead time. And the so-called safety stock is the extra stock that you keep really to take into account the risk of not being able to satisfy this. So if you want to have a 90% service, you take into account the demand variability, so you need to have a probabilistic forecaster because the variability impacts that, and it's really, in a sense, proportional to the demand variability. The other thing that you have in this kind of business is constraints. Lots of constraints. There are capacity constraints of production, of budget, things they can buy, or on storage. You cannot put everything in a warehouse, or on time, on labor, because you have to do something or move something, and you have a number of people to do that. There are integral constraints, so usually when you order something, you have to order at least a minimum amount of quantity, and it comes in lots. You can order by 100 and 100, not I will order 35, and then there are units of measure. So you have a pallet, there is an amount of boxes, and inside the boxes there are a number of SKUs. And this introduces a lot of constraints, and then there are, let's call them general feasibility constraints, or schedules, opening hours. And so the part of constraints is where the techniques from operational research come in and help handle that part, because that's what they're made for. And it's a really interesting part. I have a background in forecasting, and I'm starting to study a little bit more about that. Now project more in that area. So, now, we'll talk briefly about forecasting. And forecasting in the supply chain domain, not in general, but in the supply chain domain. So the first thing that you have to do is to model. So you have to forecast the time series. And how many time series do you have? This depends on 3 dimensions. The dimension of product, which is the number of SKUs, stock keeping unit that have, or item references. It depends on the number of markets, so primarily physically on the warehouses, but usually when you want to model for a demand forecasting problem, you break down that a warehouse can serve multiple regions, and can serve multiple customers to different channels, e-commerce, not e-commerce, and you want to break down to some kind of definition of market that makes sense for your business. So while usually the product is something that you do not model too much, it's something that is given to you, the market is something that you decide, in a sense, as a data scientist, what is the correct level of aggregation that I want to aggregate the demand for the market, because that should be the level in which you have a good information to signal ratio. And then you have the time, because different industry, they have requirements that you need to satisfy order by months, weeks, days, in principle also some days, but I never work on it. The minimum amount I work is days, but there are probably industries where you can do something like that. So basically, if you have, 1,000 products and 100 markets, and you think about doing a weekly forecast, this gives you, for example, the dimension of your data sets. And in supply chain forecasting, they are not very big. The thing that you have there is the complexity due to these hierarchies. So because you have family, brands, a hierarchy of attributes for the product, for the market, and you want to be able to take into account that. Just very briefly on the algorithms that you use, the traditional one that are used in supply chain forecasting. So this is something that I learned on the job. Instead, usually in statistics you study a lot about ARIMA or other that are more econometrics models, while in supply chain the workhorse is the so-called exponential smoothing. So it's an averaging over an infinite window with decaying weight. Very, very simple. But you use it in very simple models, in which basically you are modeling the expectation that you have on a single variable, and you are updating that expectation every moment of time with what is happening now, with half of what I thought before was the expectation. And the simplest models that are used are hot winters, in which you have 2 exponential moving, one for the trend, not only for the average level, but you also have a trend and a seasonality. And another one which is used for example in spare parts and in intermittent demand is crosstalk, in which there is a trick in which you have something that is something that is ordered once every 3 months and in a certain quantity, very sparse demand. Then you model separately the moment in which you have non-zero demand and the quantity in which you have demand, and the inter-arrival time between the moment of orders. And these are the basics of this. Then what happens is that these are evolved, and you can evolve them in different ways. Usually you add in some way on top some machine learning, and you can take different approach to that. Let's say the categories of this approach are boosting methods, because something like IGBM is very fast for forecasting lots of time series. And this can be tricky in terms of producing a forecast for the supply chain, because sometimes you want to be able to interpret a little bit more. So you have to be careful how you use it. So I would say that still a lot of the industry is more on the left side than the other side, and more of the research or the advanced places are on the right side. So the neural-based time series forecasting are something that is really something that only top places are moving there, and we are not there yet for foundational models which just started and which do not make at the moment too much sense, but something interesting for the future. And then after modeling, you have to evaluate your forecast. So in supply chain, one of the very important things is the bias, that you compute not only at the whole aggregate way, so but on every aggregation. So you look at the bias by family, by region, so all these aggregations that are important for the complexity, because you don't want to have a forecast which is unbalanced. And this is, for example, one of the reasons why machine learning is not so easy to use, because it's tricky to have a good bias. You have to use tricks in order to not have a bias in some small category in which you do not have too much things. The other workhorse is the looking square error, but it's also useful sometimes the May, in which you have, when you have peaks, for example, and promotions, and you don't want the errors to be biased too much by big errors. Fortunately, very much in the industry there is used the MAPE, which is not very good, because basically it's biased toward lower forecasts, and a lower forecast, the lower the error, and it's not a good measure. And there is a very nice article that explains all about it. But these are the basics. When you want to, yeah.
So, would you not use MAPE even when you're forecasting like dollar amounts?
No. No, because if you forecast less, it has some stuff in the denominator that tells you that the forecast is just better if you forecast less. Depends, and then maybe it depends on what you want to put the forecast or the demand on the denominator. But the things that you put there is something that will reduce your error.
I get the fact that MAPE is bad because it adds the bias, because the percentage is, if it's low, it's lower, yeah, and the percentage is greater, stuff like that. Is there a better metric that captures like the dollar per dollar improvement, or like the degradation when you swap out models? Is there a better metric than that?
So
a lot of times I want to know, like, how much is it saving me? How much is it costing me by doing this new model?
Yeah. With respect to the cost, I would say that, let's say that when you want to develop the models and you want to optimize them in terms of the accuracy to forecast, you should not use the mapping. Then, if you want to report something for the business and they need to understand with percentages, yes, then it's fine. The only important thing is that you don't use it as a thing that you say, okay, now the forecast is better because the error in MAPE is more to, okay, if you have to estimate what is the dollar amount that you have removed. That's the problem. Yeah, because there is a problem of the fact that you are aggregating completely different products. So you have to use a unit of measure that makes sense, which is usually volume or cost.
So maybe like good for communication to stakeholders, but you shouldn't be using it in your testing and training.
Yes. And you should manage the expectations in terms of, okay, they maybe went down this month, so it was a better forecast. It was a better result.
Sweet.
But a very interesting place to understand a much more sophisticated evaluation is the M5 competition, which is a competition that went on Kaggle with Walmart sales data. And I would say in that area, in supply chain forecasting, has become the most relevant open benchmark. It's called M5 because there is this Greek guy who ran a number of competition in the area of forecasting in general, and that specific one was important for supply chain forecasting. And there is a particular weighted way of a root mean square scaled error that is particularly nice way, and you can find a lot of information. It's also a competition that had two versions, the accuracy and the performance one. So there is no one here giving me the number of minutes, right? So I think we have 5 minutes.
5 minutes.
Okay, so I will start to run a bit more because to my time. So other problems that you have when you do a forecasting is not just forecasting the time series, but forecasting a number of other elements, for example. And these were one of the things that in the specific part of the product I worked on the most. Forecasting the seasonality of something, so the fact that a particular profile in demand reproduces year after year, or inside the month, or inside the week. So sometimes you refer as multiple seasonalities, this kind of different periods. The fact that sometimes you have a lot of promotions, so you have to be able to somehow correlate some market drivers like discounts or special offers of some kind, or the fact that a promotion might work better on some product or some markets, and you have to calculate an uplift. And another problem is the initialization problem. So product life cycles are shorter and shorter, you have more and more products, and when you have a new product, you don't have historical demand to base your forecast on. So you have to guess based on past performances, and how do you initialize the forecast. And I have a talk about time series forecasting more in general and using Mixa, which is a very, very nice suite of open source libraries for forecasting with Python. And basically, this group of people took, in the past, R was the best word to do time series forecasting, and Mixa raised it to the level of excellence also for Python. Okay. Well, stories. So, yeah? 5 minutes.
Yeah.
5 minutes, okay, take a couple minutes more. So I was building this functionality to initialize the forecast, indeed, to forecast a new product. And we built this nice model that had an error that was much lower than the baseline. And what happened is that, okay, I have a good model, but they don't want to use it. And why? They do not trust it, because they are used to a different process. So it was built on machine learning, they did not understand it too much. They are used to a process in which regional people give you their estimate of the forecast, something like that. And so this is a problem in which knowing a little bit of domain helps. We try to build an interpretability tooling to help them trust this. But when you start using interpreter and model, my experience is that you start to trust less the model yourself when you look about it with sharp values or something. And it's hard to then have the user trust it. Then another moment in which the domain is important when you have a data science project, which is something that I think is very interesting, is to think about the data generating process. For example, when you explore the data. Recently I was looking at this data in a new domain that I didn't know about, really inside the warehouse, in which you have orders that come in the warehouse and orders that come out the warehouse. And if I look at the data and I say, okay, I have 100 orders coming in and 10,000 orders coming out. Oh, how is that possible? There's so many things that are coming in and coming out. The thing is that in a warehouse, suppliers give you pallets of the exact same thing. But for example, if you ship to retailers, the pallet that goes out is different kind of products, because in the shop you cannot put a pallet of things. You put a box of this in the shelf, you replenish a box of that, and so on. And so thinking about the data generating process and where it actually happens, and visualizing this kind of things, I think it helps a lot also when you explore the data. And for example, when you have a missing day in the data, maybe it's because the Wi-Fi went out or anything. Another important thing I think it helps is to go with the first rule of machine learning, to start without machine learning. So you build something in which you identify what you want to build, and you really try to build the zero element of machine learning, naive forecast, greedy algorithm, whatever. And then you build on top of that. Then you have to talk to experts. And in order to talk to experts, one thing that you have to become better at doing is interviewing, to find the pain points and to find a way to understand their language and to ask them the right question, and also about the availability of data. And one thing that I think it helps a lot when talking to data experts is to build an interface. So I use a lot, for example, Streamlit, to build and show interactive tools, and it helps a lot to talk with experts. You have to document domains, something I started to do, to add very few lines about business, domain, and data in the README. So a company, so really few lines that do not change too much, in which you pin down, okay, a company is doing this because they want to reduce cost. And the cost is tied to this part. And something that could help is this, and the data availability is 2 years, but quality is just 1 year, and it comes from a specific place, the warehouse management system. So thinking about the data generating process. And sometimes I had this issue with the fact that I thought, okay, XGBoost came out so many years ago. I say, okay, let's move the system we have built from random forest to XGBoost. And one thing I found out is that boosted trees can predict out of range, and you don't want to predict something which is negative. And if they predict out of range, you can have to adjust the bias. Plus, our solution was really an automated solution, and boosted trees are slightly different calibrated than random forest. In the end, we moved it to boosted trees, but something that when you work close to the domain, I've learned is sometimes you have to resist the hype and always watch the results, because it's not just the metrics that matter. And you can learn domain from socials, from books, but also from experts. I've used YouTube videos to learn about new domains, and you can get inspired by the domain. So this is something that, one new thing that I have started to work on. And I think I will probably skip it, and I will tell you. And I am think you're now convinced that domain is important. You were already convinced. You were not before. It's more complex, and maybe you're inspired to talk now. Thank you.